As we begin algebra, let's take a look at symbols and sets of numbers. The first thing we want to notice is that we have several different sets of numbers and they're all sort of related to each other. I want to start with the smallest group that we have here, which is the natural numbers. And the natural numbers really are the counting numbers. They begin with 1, 2, 3, and so on and go up. You'll notice that they don't have any numbers smaller than 1. Let's go up to the next group and we'll find the whole numbers. Now what we've added with the whole numbers is the number 0. So it's really the natural numbers plus adding a 0. The next group of numbers we should be familiar with are the integers. For integers, you'll notice that I've added the negative numbers. So I have 0, 1, 2, and 3, and I also have -1, -2, -3. It would be whole numbers plus negative numbers would give me integers. And then come the rational numbers. For rational numbers, I have whole numbers, I have natural numbers, whole numbers, integers, and I'm also going to add two other sets. I'm going to add fractions, and I'm also going to add decimals. So numbers that are not complete, that were parts of numbers that represent partial quantities, fractions and decimals get added for rational numbers. So if you want to look and say rational numbers include, you can say anything that would be included in this list would be a rational number. In other words, integers would be included in rational numbers, whole numbers would be, and natural numbers would be also. We do have one other set that's a small set, and it's called the irrational numbers. Now those are the numbers that are not so easy for us to see. The square root of something that doesn't have a perfect square root, the square root of 3, for example, or 2, and then something like pi, which has no definitive end. It keeps going forever. It is a decimal that doesn't end for us. So those would be irrational numbers. If we consider the two major sets that we have, the irrational numbers and the rational numbers, we make up what is called the real numbers. And this gives you just an idea of the number systems that you're going to be working with and some of the names that you might have to be familiar with. What difference does it make? Well, let's take a look. Below this, we're going to be comparing some numbers and seeing if we can figure out which are bigger and smaller and which ones are equal. So we've got some statements. In example number 1, we have two numbers, a -2 and a +2. What we really want to know is we want to put a sign in there, a symbol that tells us the relationship of the -2 and the +2. And our symbol, of course, is the less than sign. In other words, we could safely say that -2 is less than 2. Example number 2 is fractions, which have a tendency to confuse us just a little bit until we realize that these fractions both have a common denominator. When they have the same denominator, all we have to do is compare numerators to see which one is bigger and smaller. We have 18 thirds and 24 thirds. There are more thirds over here. The 24 is more than 18. So our symbol that we put between the two of them is, again, the less than symbol. Now, if you can't remember which is less than and which is greater than, just point the arrow. The little point goes toward the smaller number. The big end of your arrow goes toward the bigger number, and that may help you remember. Next, we're going to look at decimals. Number 3 says 2.13674, and we want to compare it with 2.136632. With decimals, you start with the leftmost number, and you're comparing place values. Well, this 2 and this 2 are both in the ones place. Then we have a decimal. They're identical so far. The next digit in the tenths place is a 1. So far, they're still equal. The next digit is in the hundredths place, and it's a 3. They're both 3s. The third digit, or the fourth one here, is in the thousandths place, and it's a 6. They're still identical. This digit, the next digit I come up with, is different. And that's the digit that's going to determine for me which number is bigger. The 6 on the right is smaller than the 7. So I'm going to point my arrow toward the 6, the smaller number. In other words, it would say 2.13674 is greater than 2.136632. Now let's take a look at example 4. We have two numbers, but we don't really know the value of them until we resolve the absolute value sign in the first number. I have to say the absolute value of -5 is +5. Well, the absolute value of anything, if you remember, is a positive value of the number. So I'm really comparing a +5 and a -4. Of course, the positive 5 is bigger, but I needed to resolve absolute value before I could tell. Example number 5. 3 is a positive 3 and a negative 5. Well, anytime a positive number is always going to be bigger than any negative number, isn't it? So I'm going to say 3 is greater than negative 5. And finally, I have number 6, which is the absolute value of 0, which is 0, and the absolute value of negative 8, which is 8. Remember, absolute value, we take the positive value, the distance from 0, and distance is always positive. So I'm going to say 0 is less than 8. I would put a less than sign in there. Now, example 4, they want us to translate these. How would you write 5 is greater than or equal to 4? Now, we've used the greater than sign, less than sign, but a greater than sign with an equal under it is written greater than or equal to is written like this. We just add a line under the greater than to make greater than or equal to. So I'm going to put 5 first because that's what's first in my number, and then I'm going to say is greater than or equal to. Well, that's the greater than or equal to sign, and then I'll put the last number, 4. I'm just translating it straight like it is written in the statement. Most translation is done just that way. Try number 5. Negative 10, I can write negative 10, is not equal to 7. The only thing I don't know how to write is the is not equal to part. Is not equal to is just an equal with a slash through it. That means that it is not equal instead of an equal sign that doesn't have a slash through it. This is your introduction to numbers, and we're ready to get started in the rest of algebra.